That help? A few heads are nodding. Yeah, okay, thanks. So I was hoping that I would stimulate questions from you so that you could ask what you really want to know about rather than what I want to tell you about. I've put in some historical material sort of partly to provide some context and mainly to try and be entertaining so that you'll all come back again next week and I can mess with your minds some more. So really what I've tried to do is bring together some material that talks about sort of what it's all about and why, what's the rationale behind it. And here on this slide I've added at the end who's the victim of this crime. So context, like I said, some history. It really does go back 10 years, and this is trying to summarize what was going on at Microsoft at the time. We had OS2 going on and Windows 3, and we had this funny little skunkworks thing called NT-OS2, with half a dozen guys working on it at the time. And this was kind of the range of products and the kind of machine we were working on. And the relevance of this will come out in a slide or two. Out in the world, some other interesting things were happening. There were integrated products like Interleaf and Xerox Star automation systems, a bunch of toolkits and Windows systems, different languages people were playing with. I've noted Accent and Mark on there partly because I have had personal experience with those things, and that feeds into some of the thinking that happened. But that's sort of the operating system activity that was going on. And in the middle of all this, we were trying to say, well, what is our future set of goals for, in particular, applications? The systems group were busy with trying to get PM and Windows to work, but for applications, where were we going? And this set of objectives was at least what they presented to me when they were trying to hire me. Okay, we're trying to say, let's have some common architectures and shared technologies in the applications, aiming towards a sort of integrated office automation environment. Okay. And with full extensibility and customizability and so on. Of course, we were going to do it on a 386 4-megabyte machine, right? And at about this time, well, okay, so what happened was we said, how are we going to do all this stuff? What's going to make it possible? And so the word was something. Actually, the word was objects. But for all the difference that made, it might as well have been Gesundheitsplatz, because everybody knows what an object is. The only trouble is everybody knows different. And so we went into the first object war. And we had a group of people, a task force, the usual stuff, arguing back and forth, brainstorming. PM++, because PM was our future, remember? C++ clearly didn't have enough features in it, so we needed more. Dynamic inheritance, there was an object-oriented file system. The application factory was this thing where you could sit down in an afternoon, you could spit out Excel. All on a 386 4-megabyte machine, remember? And Object Basic was being kicked around at the time. And there was this perennial issue that nobody really, really wanted to have to think about, which is, do you build a spiffy new framework where you can do everything nice and right, or do you try and address the existing applications? And we never answered that question as far as I can tell. All right, we still haven't. And of course, because this was back at the time when we were in the joint development agreement with IBM, IBM had gone off and licensed Nextep because they had lots of cool technology. And so we were writing slides that says we're going to do all this in 18 months on a 386 4-megabyte machine. So this was the sort of ongoing discussions and design thinking and things up until, I don't know, 89, 90 sort of era. Sorry, I lost the thread of what I was going to say about that. In the middle of this, my manager at the time, I was involved in a lot of these discussions and arguing with people. My manager at the time said, this is going to take a while. So spend almost zero time worrying about that and spend all of your time worrying about the upcoming Windows opportunity. Because summer of 1990, Windows 3 shipped, so that was imminent. We had a family of applications in development. There was potential that we were not realizing to do something interesting there. And a piece of this, which I had been peripherally involved with, was the situation with PowerPoint and Excel. PowerPoint at some earlier time had put in their plan that they were going to develop a graphing package, because PowerPoint's a presentation graphics thing, and you need to show your manager graphs. You need to show your customers graphs. And Bill's response was, no way. We have this product called Excel that does graphs quite well, thank you. You will use that. So the PowerPoint and Excel groups got together and they looked at each other's code and they both said, yuck, I'm not having that anywhere near my code. So they spent some time figuring out, okay, what the Excel group would do was build a cut-down Excel that just did graphing and didn't have all the spreadsheet functions. And PowerPoint would implement some code to talk to it through this dynamic data exchange so they could get the graphs into the PowerPoint slides. And that way they could sort of keep their mutually distasteful code at arm's length. And one of the observations I make in hindsight is that this environment of mutual distrust leads to a very strong interface definition. Okay? And we might bear that in mind when trying to do this kind of thing in the future.
Is this where DDE came from?
DDE already existed at that point. It had been prototyped, well, I mean shipped, but we ship prototypes in this company. It had been prototyped in Excel using Windows 2 as a way to get data in and out of Excel in a more dynamic way than cut and paste under a sort of programmatic control. It wasn't heavily used, but it was used. And Lotus and others picked up on it and used it. So what I did was work with the PowerPoint group and the Excel group to say, okay, let's take this protocol for message exchange that we use to achieve this embedding of graphs and generalize it and standardize it so that it's not unique to PowerPoint, it's not unique to Excel, because we're going to have a whole suite of applications coming out that we want to integrate in this kind of way. And I learned a few things, like Word, which was not yet shipped but in development, they wanted to have DDE support, and they had taken Excel's code, but it no longer resembled the original. They copied it and hacked it to death and spread it throughout their product and so on. So it meant that for me to get each of these products to go implement this protocol, they would have to, because it's more than just the DDE protocol, it's layered, they'd all have to do it individually because of this copy and modify approach to software that was going on at the time. So, of course, in thinking about how you generalize this and turn this into a more of an application integration environment, I came up with this thought experiment that says I'm working on my memo on my computer and I go away for lunch, leaving it there. And while I'm out, I hear about this new drawing tool that's very useful and people tell me it's good, so I go and buy it and return to my office. And my memo's still open. I didn't shut it down or anything. And I install the drawing tool, put the floppy disk in, and so on. And then I go back to my memo and say insert object, and I get my drawing. And that was the thought experiment. I said, that's what we're trying to do with this stuff. This being the very simplistic first steps. It was quite interesting to me when several years later I got an email message with a little icon in it that said double-click this to install an AVI player, and then double-click this thing, and you can watch Neil Carlson crashing his car at the racetrack. Which was, this thing in mail instead of floppy disk, which was quite nice. So meanwhile, this other group that was going to solve the world's problem with objects was still working away. And I was thinking to myself, okay, we want to do some added value integration in our applications now, but is there any way I can make it be a step on the way to this future world that we're going to have? And in the course of trying to figure out how to do that, I was communicating with this objects group and saying things like, well, here's a scenario. How's this going to work in your world? So I could think about how to map it back into my world. So I would go through this drawing tool example that I just had, or I'd go through the graphing example. And I would say, exactly how does this DLL that gets installed, exactly how does that get hooked up to the word processing application and so on? Because these details were not clear to me, and it seemed to me that they were important. And what would happen typically is that I wouldn't get any immediate answer, but sometime later a spec would appear with a new chapter in it describing a set of charting classes that you can subclass. And that was sort of not the answer to the question that I asked. The answer, I said, how do I put my graph into his word processing application? And the answer I got was more about how I could take the charting classes from the objects group, and the word processing people could put that in their application. And I'm saying, well, where's the room for me in this? How do I play? How do I add any value here? But I observed that this was an attempt, or rather a response, to try and make the problem go away. The problem that's hard is how to specify the interactions between these things and do so precisely, these independently developed things. And the response this team was giving me was to say, well, we'll provide the implementation, so then we don't have to tell you about how they interact. And so you suck all this stuff into your control, and then you don't have to describe how it works internally. You only have to talk about how you customize it. But it doesn't solve the problem. So I took a defensive strategy that said, I don't know where that stuff's going. What I'll do is I'll define an API for how an application should talk to these objects, quote, objects that are being embedded. Very simplistic API. So that I can put something radically different behind that API later. Nobody believed that this was a good thing to do. So I got a summer intern to prototype it and show it to people. And people started to see it then. They started to understand it. We put an implementation of this stuff into card files so that you could embed objects in your cards in card file. And, you know, card file is this tiny little toy. But when I showed it to people with an Excel chart in it and a bitmap in another page and different things on different cards, they started to see, oh, maybe there's some value in this. We demoed it to Bill back in the days when you could still get access to Bill. And the next thing I knew that Bill said, this is good stuff, I want to put it into Windows 3.1, which at that time had a delivery date of April 91. And this was like August of 1990, so there's not a lot of time. So just for fun, I drew up this timeline. At the end of August, my intern left. In September, I got the first developer with no overlap. So he's coming in not knowing anything about the design, not knowing anything about the code. And then other things kind of came up to hit me rather quickly. Like in November, Comdex was coming up and they decided to do a demo because it's cool technology and it shows off Excel and stuff. So VPs need a demo. Prior to Comdex, there was a press tour, so they needed a demo on a luggable that they could carry around and show to people. And this is, 2 months into coding at this point. And then the developer relations group that was just ramping up decided, we'll have a developer conference and scheduled it for December 12th. At which point they needed, be able to deliver code to people, give them samples to show them how to do it, have documentation, have a big book of slides, because we're going to have a whole day of presentations about this stuff. When I look back at this, I think if I had seen this in August, I would not have done it, is all I can tell you. But in the course of this, the reason I'm going back over this old history, this was all A1 that shipped, did indeed ship in Windows in June of 91 in the end. Some of the basics that appear in really fleshed out form in COM were there, and that's why I'm bringing these up. So some of the things that were there, the API was vtable based, just like it is in COM, to allow for polymorphism, so that you could, in principle, load different DLLs with different implementations and get at them through this vtable. The vtables had the query protocol at the top of it to allow for extensibility. It wasn't very well fleshed out as to how that was all going to be used and so on, but it was a hook that I wanted to put in there. Another innovation there seemed to be this notion of site objects. And I can best explain this by referring to, let's say, Windows dialogues. In the Windows Dialog Manager, controls that are on the dialog are given an identifier, and when they send a message to the dialog, they send that identifier along to say who's calling, so that the container can identify what action it needs to take dependent on who called it. So, if the button says I got clicked, you'd like to know that it was the OK button rather than the cancel button, as a trivial example. And I thought about all the various possible ways that you could do this, and who manages the identifiers, and all sorts of issues like that. And I said, I think I can abstract all of that. I can give each object, try and point with it. I can give each object a unique site that it sends messages to. And it doesn't have to send any identifiers along because they're one-to-one. And inside the site, the container has stored whatever it cares to store to identify that object. So it could be an ID that it's assigned, it could be a pointer to some internal data structure that it's maintaining, anything it wants. All I've done is to try and abstract that notion. This is something we reiterated again in COM, or rather in OLE 2. And I don't know how people react to this notion, but it does seem to have given us a degree of flexibility that doesn't show up in other object models. If you look at the Java windowing classes and so on, they don't have this. And they find certain inflexibility in things about how they do message routing and stuff, because it always has to go to the container, and you can't intervene without knowing everything about the container's namespace and issues of that sort. So this was just an interesting way of abstracting that one piece of the problem. So some more features that showed up there was, first of all, the notion of a pseudo-object. This is a thing which, when you're invoking operations on it, looks like an object. But its implementation doesn't have to be anything like an object. The prototypical example here is that a cell or a range of cells in an Excel spreadsheet, you'd like to be able to somehow get a reference to that thing and talk to it, invoke methods on it, like, paint yourself green, or clear out the formulae, or methods like that. But you don't want Excel to have to implement its cells and ranges as objects in order to make that possible. And again, other object-oriented frameworks don't seem to have hit upon this. They've got other techniques like flyweight objects and so on to try and address some of the problems. But they don't really have this notion that you can have some big thing that can, on request, give you what looks like an object that accesses parts of that larger thing. I mean, you can fake it in some of these languages, but it's sort of not. It's not really been adopted in the frameworks very well. The other aspect of what I was trying to do, I mean, I talked about abstracting what's going on under the covers behind an API. What I wanted to do was have that API or interface model be scalable in the sense I'm trying to express here. That when you're just calling some lightweight object that's in your process, in a DLL or whatever, that there isn't any big overhead. But that when the object is in another process in the graph case, that all the heavyweight mechanism of sending messages and doing the protocol is hidden behind that same style of interface. And I contrast, for example, here I put accent and Mach, where the model of IPC and network communications, in Mach you had a port which you could use for IPC, and in the case that the thing you wanted to talk to was across a network, there was a proxy process in place that would handle all the networking. And the client of this didn't know the difference. By contrast, in BSD Unix, if you wanted to do IPC, you had to do TCP protocol between processes on the same machine. Okay, so they used networking to implement IPC. Mach used IPC to implement networking. So I was taking the Mach approach with this interfacing model. And again, this distinguishes COM from Corba, for example. If you wanted to talk object to object in Corba, you've got to go through all their network plumbing. They've recently started introducing shortcuts, but they started at the BSD type model. So going into this design, the sort of ideas that I was taking in with me was ideas from abstract data types, that you separate interface from implementation, you get substitutable implementations. And we wanted to address this dynamic installation of classes. So that you can bind to a class that wasn't there when you were compiled, it wasn't there when you were installed and linked, and so on. You guys are all very quiet. I hope you're saving up good questions. Or am I not being provocative enough? So having got OLE 1 on the way, we started thinking about how do you go beyond this, because people could already start to see the value of this kind of integration. They thought, at that stage it was just compound documents. How do you put this kind of thing in that kind of container? And it was limited to that. And we started looking about, well, what more things are people going to want? And we talked to them to find out and so on. And we came up with this list of things. I'll just talk about one or two. dealing with large objects was going to be important because of multimedia video files and so on. I saw a mail message float by once that said, "Why did my machine hang when I dragged this thing over into this Excel container?" And the giveaway was that this little thing had a suffix of .avi. So I just said, "How big was that thing?" And, you can picture the answer. Well, that's it. It's just and what can you say? I mean, if you can drag the thing, your expectation is that it will work, right? And of course, because this was DDE, what was really happening was that this file, 8 megabytes of video, was being loaded into memory on a 16-bit segment swapping machine with 4 mega RAM in it. Okay, so no wonder it hung. And it was being copied a couple of times on the way. At that point, I wished I could have a motorized mouse so I could make it really hard to drag something that was too heavy. Somebody's building one now, there's a force feedback mouse. Extensibility and programmability became kind of pretty crucial at this point. Trying to get customers to build their favorite solutions using our applications is something we wanted to achieve. And so OI automation and VBA and things were happening during this time. Also trying to soften the hard boundary between the object and the container so that more rich information can be exchanged about, can we do non-rectangular layout? Can we flow text around funny shaped objects? Can we take footnotes out of the embedding and stick them at the bottom of the page? Lots of stuff like that I characterize as this sort of translucent containment. It says I know a lot about this thing, but not all about this thing. And I was sort of coming to the realization that what we were busy defining was some kind of add-in model that's independent of what the add-in is and what the container is. And when you put all this together and say, what's the set of requirements that's really going to drive this design? Substitutability of objects is clearly important, because if you have to do something special in the container for each type of object you're talking to, you don't get that arbitrary extensibility. Because these things are coming from different vendors, and Microsoft product groups were more or less different vendors back in those days, these things have to be able to evolve independently over time as they add features and do new implementations and so on. And you don't have any central point of control. Certainly in the market at large you don't. And we might have tried harder to do some more central control within the company, but it wasn't going to work more broadly. If you're going to allow this evolution and things are going to sort of go out into the marketplace independently, you do have to start asking a question about this bullet about down-level compatibility. What happens when an upgraded client meets a down-level object? And I'm not sure what I can say, but people will actually go and build class frameworks without answering that question. And I find it amazing, but it's true. Again, because it's multiple vendors and things, you don't want to constrain how they build their products, what language they build them in, and so on. So you want some kind of language-neutral way of hooking them together. And you also don't want to require that everybody builds their product on the same application framework, because otherwise, they can't. If they've already built the product and it's not built on that framework, they wouldn't be able to play in this world. And I'm sort of saying that, well, really, if you look at this set of requirements, this is defining what it means to have a model for an open system. This is open with a small o, not open with a capital O. And for me, this set of things defines an open system. It says anybody anywhere can walk up to it and add something into it. And this set of requirements is what really leads to what we did with COM, is trying to address all of these problems. So the sort of, again, the context for thinking about this design and ideas that we took into it. Things that were out there in the world were things like the Next Step environment. They were using Objective-C, had added this notion of protocols to Objective-C, which is very, very similar to COM interfaces. The Andrew toolkit back in the past had used a very similar model. Apollo had done some interesting work called extensible streams. This was in their operating system. And they only ever built things with a single interface, which was a stream interface. But they used it for coupling up pipelines of protocol processing and things like that. It was rather like the Unix 8th edition streams, only different. And they again had this vtable-based idea to separate the caller from the different kinds of implementation you could put behind it. And the last point I want to make is, because of all the bullet points on the previous slides about open systems and so on, we took an approach of the principle of least commitment. That is to say, we make programs that are going to talk to this thing, we're going to minimize the commitment they have to make in whatever ways that we can think of. Since we shipped this stuff out, we've had a lot of complaints from all around the world about how impoverished COM is as an object model, how it doesn't do this, it doesn't do that. And that's because of this principle. The idea was anybody building a product can do anything they want inside the confines of that product or the things that they control, but when they talk to the outside world, they do it through this narrower set of functionality and interfaces called COM. Because if they try, well, it's not going to work if some product tries to impose a certain set of conventions or conditions on other product suppliers. Okay? So if somebody wants to do garbage collection in their world, and they want me to put support for garbage collection into COM, that would imply that everybody who wants to use COM is going to have to understand garbage collection. And we just try to say, no, we're not doing that sort of thing. We're just trying to do the minimal thing that will get these environments coupled up. So there are a number of things that we came up with, and clearly one was to actually exploit actively this notion of multiple interfaces on a single implementation. This allows us to support optional features in the implementations. It allows us to increase the set of interfaces and therefore the degree of integration over time. I came up with this notion of, well, if I think of this object as having multiple facets and each facet is an interface, and query interface is this operation that sort of rotates it, so I'm looking at it slightly differently. I also observed during this phase that version compatibility is the same problem as substitutability of independent implementations, because it's the substitutability that matters, not what the implementation is. I kind of picked up on this when I realized that Lotus wanted to sell 123 as a competitive upgrade to Excel users. And they wanted the users to perceive it as, my spreadsheet got better. And of course Excel wanted the same thing in the other direction. And it really came home when, I believe it was Word 6, did a better job of compatibility for WordPerfect 5 users than WordPerfect 6 did. Okay, thereby winning a big chunk of the market share. And the point I'm making here about this is that the ancestry of the code is really second order. Okay, it's the compatibility that's the first order question. And checking that this code from Lotus is substitutable for that code from Microsoft is the same problem whether this is a spreadsheet and that's a spreadsheet, or whether this is a graphing package and that's a drawing tool. And the other area that cropped up a lot in exploring these scenarios is what we call three-body problems, where A creates or obtains some resource B and gives it to C, and C will then use it. A typical example is a container connects to a printer and gives the printer thing to the object and says, print yourself. And the goal was to allow B and C to have a richer communication than A knew anything about. So B could find out more, even if A didn't know how to ask even for that service. So if it's a color printer and the image knows how to print itself to a color printer in a richer way, does your word processor have to know about color? And we wanted to design it so that you didn't have to do that. When you wanted to version some piece, some relationship between two components, you didn't have to spread that knowledge of that extra richness through the entire system. And that's why query interface is there. That's why it's in COM. By the way, that through-body problem is also a classic proof that the version checking in systems like Corba is unsound, because they do version checking either at load time or bind time or something to the object. And when you pass it off to the third party, there's no version checking done by the system, and so he can break. So this is what we came up with. Query interface with some formalized rules about what it should do that we didn't have before. So you get transitivity and all that sort of things. Reference counting. We separated the instantiation step for the object from its initialization. It's unclear exactly how valuable this is, but the main reason we did it was to get this extensible set of initialization interfaces. So you have a standard way to bind to the code, and then a customized way to talk to the thing to initialize it. And again, this scalable interface model that we first thought about in OA1 is used in spades in COM. I have no idea how far I am through the slides. The other thing that we did was we built the infrastructure out of components. This is, again, harking back to this notion of using IPC to implement your networking rather than the other way around. So storage was a set of components. Monikers were a set of components. The marshallers were a set of components. The RPC channel was a component. Things you build up on top of that are, of course, components. Because of the multiple interfaces on one object thing, we had to invent some notation. So we came up with this lollipop diagram. The lollipop represents an interface, and the blob represents the component that's supplying it. We paid attention to the notions of design by contract and said that an interface is more than just a set of signatures. There's an associated contract for how you use it properly and how you implement it properly. And I'll talk a bit more about that in a minute. But these contracts are what gets to the issue of substitutability. If I don't implement the same contract, I'm not substitutable. And then allowing people to add interfaces allows the system to be enriched without having to start over. So again, it's not just you can add new components in, but you can add new interfaces in, which other people can then pay attention to. And you don't all have to come back to Microsoft and say, please extend COM for me. Okay. Which another, I think is an important point. And in thinking back about this, it's a recurrence of this problem I was talking about with the object spec that was growing in class charting functionality and stuff like that. If you break things into components and define all the interfaces, it gives you a lot of flexibility. You can pull things out and put different things in, especially when you do that in the infrastructure, in the middleware itself. On the other hand, providing standard implementations of things like storage, like the OA default handler that handles caching of metafiles and so on, that makes it easier for people to start using the stuff. And there's traditionally a tension between these 2 points of view, because the framework style approach says, I'll provide you all the standard implementations you need, and you don't need to tunnel down under the covers any time. So for example, if you look at Smalltalk, it's easy to do a lot of things in Smalltalk because all the objects live in the same virtual machine. And you can trace all the pointers, and you can find all the variables and persist them and things like that. But COM doesn't do any of that. It doesn't say, I know everything about you and I can go behind your back and do things. So I'm kind of coming to the conclusion in the end that maybe COM, what COM's really about is interoperability between different virtual machine environments. And of course, we've got lots of virtual machines these days. We have the Java virtual machine, we have the COM+ virtual machine coming, we have the Visual Basic virtual machine, we have the Excel virtual machine, we have the Word virtual machine. Word is an operating system. Word has a scheduler in it. So, if you would ask them to give up some of that stuff into this common virtual machine, that's a very hard sell. And COM was about a way to make these things interoperate with each other without imposing this common implementation substrate on them. All we wanted was a way to call in and out of them. So here's a way of characterizing that, what's interesting about COM. The top picture leads you to focus on, well, what's the middleware? What does it do? What's its implementation like? Okay, and you can, at various times in the past and even today, you can look at COM, DCOM, whatever, and you can say it's got these faults. And those are faults in that middleware. And they're there, they're real. I mean, it's big, it's slow, it's whatever. What I think is interesting about COM is if you pull that middleware out and you sort of go underneath and look up at the application from the underneath and say, that's COM. Okay, that's an opportunity, not a problem. That's an opportunity to do something interesting underneath here. Zoom in here. Hooking in fault tolerance and all sorts of extra goodies, transacted storage under databases underneath. There's tons and tons of things we can do because we've opened up that set of interfacing. And that's what I think is interesting to look at about COM, not the implementation of the middleware. I said I was going to talk a bit more about contracts. I'm not going to go over all of these bullet points, but reiterate that the idea of the contract is to capture the requirements for substitutability and for correct binding of things. It was only this year that I actually drew this picture to try and explain it. Most thinking about components and contracts is aimed at verifying that a client meets the precondition or verifying that an implementation meets the specification. And those are very hard problems, and I didn't know how to solve those problems in 1993. What I did was solve this problem that said when I bind, I need to know not whether you really implement that contract, but that we're talking about the same contract, not two different ones. Okay, and so the idea is to give that thing a name and then ask him, say, by name, did you understand this contract? And rely on the programmers to solve those other things, because those are hard. Okay? And the other thing about query interface is the naming scheme and the definition of query interface allows the client to ask about a contract that the implementation never heard of. The programmer who wrote it never heard of it. And have the implementation reliably say no. Okay. I mean, that's my contribution. It's just that. That's all I did. The rest is engineering. Okay, I'll pause a moment and say, I've got a series of slides here about sort of COM in action and how certain things work and so on, which could go on quite some time. We could break anyway, but I thought I'd give an opportunity to throw things and ask questions. Yeah?
One of the standard explanations of objects when you're explaining to people who haven't seen them before is, objects are nouns, methods are verbs.
Mm-hmm.
Now, I've heard from some people who looked at COM a bit that this really doesn't make, this isn't quite the model that COM uses, because COM is always talking about interfaces and not objects. So
Right.
Can you talk a little bit about that?
Yes. It should be clear, I think, from the way COM is, that it started from a perspective that was very much like objects, but added some things like multiple interfaces and so on. So the notion of object identity is there, but over time it's become weaker and weaker. And this noun-verb way of talking about things is certainly still in strong use in the modeling fields, UML and those sorts of areas. But there's a lot of deep philosophical debate going on about whether that's even the right thing, whether it's even possible to do that. Because is the taxonomy of objects universal, or is it problem-dependent? And the problem is if you change the taxonomy of the objects when the problem changes, you don't get the ease of change and reuse and so on, because you have to go change your taxonomy around. And will go along. I mean, it also relates to the issue about versioning. People say, I need the flexibility to evolve my objects, to add properties to them, and so on. And they call it room to breathe and various other such terminologies. And I slowly came to the realization that when you talk about objects, it's natural to talk about the notion of the object type, which relates to what it is. And I realized that COM interfaces don't really relate properly to object types. That what they relate to is relationships. And this also tells me why it sort of comes together with my notion about version substitution and so on. People want the freedom to change the implementation in a compatible way, which is a good thing. And so they think of it as being, well, I'm changing it in a way that's still consistent with the type that this interface represents. The problem there, though, is if you regard the interface as defining the type of the relationship, you can only change a relationship definition when both parties agree. And so my thinking is that, yeah, it is different from objects now. We're not focusing on what the object is, we're focusing on what the relationships are. And allowing the objects freedom to change and evolve over time, provided they maintain the relationships. And it is a different way of looking at things. And, maybe over time we'll just call it the component model and lose the word object. But since object never meant anything in the first place, it doesn't matter. Does that answer your question?
Kind of, but I'm not entirely sure how to better express the question.
Okay, yeah.
Yeah, one of the things I live in fear of writing a lot of COM components is I insert a control in a container, or I'm in some other mixed milieu where I know I'm going to get QI for a bunch of different things.
Mm-hmm.
What I know is that under the covers, the container that I'm embedding in, the control that I'm linking to, or the database that I'm talking to, is going to rely on the fact that it's going to be able to QI something else and give another answer. And I find that it's very unpredictable when this contract is talking about, because of the fractionation you've done with, or we have all done, participated in, across COM, the contract is now smeared. It's morphed over several interfaces, and you can't a priori know the behavior when you insert something in a container. Typically at ATL, you go in and you say, okay, what is it QIing on and failing?
Right.
And let me see if I can dig that up. So, although I generally agree with much of what you've done, and I've tested a lot of what came out of the Visual Basic iDispatch modality, okay, that's another problem, and you haven't been talking about that, or I would have asked a lot of questions there. But in this instance, what can be done, or what can be considered about looking at the extended contract?
Right, agreed. There's been a little work in that area. There's this idea of component categories that got kicked around.
Done very badly. There's lots of funny tags in the registry.
Sure. Yeah, there are a lot of issues there. I mean, in part, you could say, well, it's a matter of documentation and specification. If you want to put this thing into this container, here's the set of interfaces it must have. Or you could take an approach where you want to formalize it. What we've talked about in my group a lot is this notion of types which span a set of interfaces and have an associated contract for the whole type. And that you could articulate that given an identifier. And then some container could say, in his documentation, he could say, if you want to embed in me, you have to implement this type. And you could formalize it that way. It hasn't been done in COM or promulgated widely, but that's an approach that we're thinking about following. We've actually implemented some of that, Walt, right? Yeah. So in our work, we can define these types that refer to other interfaces and say, this type involves these interfaces, and here's the associated identifier for it.
But as soon as you change one of those, you get into the iView object EX, iView object EX2, and 3 kind of modality. Now you get a combinatorial explosion in your contract space. As you change each one of those interfaces, your meta type ones, right?
There's potential for that, yes. The thing is,
do we have an integrated test of compliance
No.
Why not?
In general, no. Well, because it's hard.
Well,
I mean, you're really, the answers to your questions really relate to what my group's currently working on,
I'm
which is
saying that
trying to tackle those
it's
problems.
very surprising to me. I mean, 15 years ago, I was working at a company. We wrote an automated network protocol test that took every single atomic state chain the protocol could do and coded it up. And certainly, it was code coverage. It had a lot of restrictions and limitations.
Mhm.
And there are standard containers here, but it seems like every time I get a new version of something, I know when IE came out, all of a sudden there were things that IE could do that none of the existing standard containers could do.
Mhm.
And I had to send mail to a lot of people to find out what and why. And somebody finally said, don't use the old standard containers, even though they came with the most recent C++. Go get IE4 and see what it does. That's gospel. Now, we don't know these things, and I really find it difficult to understand how. In other words, I'm saying I don't think you can solve this smearing of contracts. The only way you can do is with an in-situ test. You have to have a gold standard, and if it works in the gold standard, it works, and if it doesn't, then you find out why.
Yeah, but you're right. You're right. And that is a big investment to make. And we're working on that in my group for the things that we're building. I don't know how to make the IE team go and do that. I don't know how to make someone else go and do that.
No, I'm not saying that. I'm just saying that the existence of a single gold standard brings the dialogue to that level of crispness. Whoever makes
But the whole point is there isn't one gold standard because
for embedding an active executable document or container, I beg to differ. That's exactly the problem. And what I'm saying is somebody should, by decomposing what you've done, you open Pandora's box. Granted, the bats are smaller, but they're still out of the box. And that's the problem. I would like to know some stratagem that if there's anything active in the company, for finding out how to make these extended contract bindings comprehensible.
I agree that the problem exists. I'm not aware of anything really being pushed to try and make that happen. If we just had some way of whereby a programmer could define the type and publish it the way he publishes interfaces, and he could say, this is the type you have to have in order to live in me, we'd have a mechanism to start promulgating that kind of information around. People do, of course, still need the option to say, I require this type, but I have these optional interfaces.
Or advanced interfaces.
Yeah, but the thing is that if you don't have these, I can still work, and that sort of thing. And yeah, that would be good to have. I agree. And like I said, in the work that we're doing in my group, we're doing that, along with fairly hard-nosed specifications of what these contracts mean, and test harnesses to try and verify that we've met them, and so on. So, but like I say, that's a different talk. That's a talk about work in progress. This is a talk about history.
Weren't code types kind of a step in that direction?
They were, and we sort of picked up on that and said, let's give code types some teeth, and try and add more to
I don't care
it.
about it anymore.
They didn't have teeth. Yeah.
Yeah, if you have components, then of course you want to compose
Mhm.
things and objects. The question is, if you do that in a certain environment, you compose an object, a complicated object, maybe in a certain environment. How autonomous or how independent is this construct from the environment? How well could it be sort of moved to another environment or reused
Right.
like somehow
Right.
completely different?
Right. I mean, a prototypical example of that is if I want to use the button control that came with Forms Cubed in Office 97. So I want to use that in my program. How much other stuff do I have to bring with it? Right? That's really what that question gets to. And that's taking the component thinking, if you like, to the next level beyond what we did in COM back then. We didn't get that far. It was just like, how do we bring these things together at all? And yeah, the next level thing is to say, I want to understand what it takes to actually bring that thing in and use it in this environment, and how much I have to bring with it, and whether there's conflict, because there often is. And this is partly a sort of technology problem in how the thing was constructed and what the interdependencies are. It's partly a packaging problem, because we bundle a number of components into a single DLL for various performance and logistical reasons. But that leads to issues like if publisher wants to use the common dialogues, they have to take this 4 megabyte DLL, right, which is way more than they actually need. And that's just packaging. So part of what we're going to need to do at some point in this company is solve this packaging problem. So we can trace the dependency and say, this is the set that I need to bring in and bring it into the system, and not have 5,000 DLLs, right? And sort of install time or bind them into DLLs or something. And again, this is all stuff that we're looking at in what we're doing. The Com Plus team is looking at some of that. But these are kind of problems that we learn by doing this other stuff. Right? If we didn't do this, we wouldn't know the problems existed. Somebody in the middle had a question, but I guess not. No more? I still got a load of slides for next time.
Okay.
Yeah.
Probably naive. I don't know anything about comedy besides what you talked about so far, so I didn't understand this question at all. But my understanding so far is that basically this is the way to get 200 pieces of code. One can basically ask the other if it understands about a particular type of interface, and so instead of having to link at compile or link time, you can put things together dynamically.
Yes.
But what does so? That's essentially 2 pieces of code that are running in the same process space.
They can be. That was part of the design goal, to make that possible. They can also be elsewhere. Let me just flip slides.
What do you mean by the terms embedding?
Oh.
That's when you have 2 pieces of code talking to it.
No.
What a container is, or
Yeah. Okay. Embedding is.
Where do you get the names for? I mean, is there like a list somewhere of the different interfaces that?
Oh yeah, there's this big spec called the OLA2 design specification that has I don't know how many interfaces in it that defines how to do embedding of objects inside containing documents. It was document oriented. It talks about how to get them drawn, how to get them stored, how to get them activated for editing, and a whole load
Those
of.
are all names of interfaces that you can follow.
Right. And so an embedded object has to implement some family of interfaces to be able to work properly in these different containers. But COM is the underlying technology that you use in all of these different cases. Okay? COM gives you a standard way to bind the interface, irrespective of what the interface is. And that's a sort of degree of generality. I just wanted to sketch this picture because this is kind of talking about if say the embedded object is this thing over on the right there, it can actually be way away. But over here, inside the process of the caller, there's a load of components that relate to how to talk to that thing. So these components are dynamically loaded in this process when that thing over there is in some other process or some other machine nowadays. And this is what I referred to earlier about the infrastructure itself being built out of components and plugged together to make the access to remote components work. And so there'll be query interface happening between these things, right? In fact, what will happen is the query interface will go to the proxy manager, and he'll say, gee, I better go find a proxy for that interface, and I'll go and load it in, and then say, yep, here it is, okay, and hook it all up so it can talk to the channel, and so on. So there's examples of both flavors of where the objects are and how they get connected. So embedding is a particular use of COM for compound documents, and is used commonly as an example of specific use of COM. Most of what I've talked about has been very general about just COM components and how they talk, not about what they do. Okay? Yeah?
I didn't really follow your assertion earlier about other OO models not really implementing pseudo-objects so well, and why these lightweight classes don't work to these sorts of things. Can
Well, I may not be completely clued up on this, but for example, with flyweight objects, my understanding of that pattern is that, so for example, characters in a document, you've got a character with a font and whatever, but you don't want to have 50 million objects for a 50 million character document. So what they do is, in effect, pool them. So if I've got a 10-point times Roman A, there's only one instance of that. And there's a sort of manager that manages the pool. And that's the flyweight pattern. What we do is we say, well, when you want to talk to an object through an interface, we surface the interface, and behind it, there's the state of the object's not here, it's in somewhere else. Okay?
You can swap that behind the scenes.
Right. And if you looked at, say, doing this with Java, I guess, no, we don't have a whiteboard. If you looked at doing this with Java, so you wanted to surface this cell object for a cell in the spreadsheet, the means by which it talks to the real thing behind the scenes has to be exposed as a method on the sheet object. Okay? Whereas COM allows that to be hidden and not surfaced in any COM interface. So the communication between the pseudo object and the larger thing is entirely private. And that allows the container to coordinate this stuff and protect itself from unexpected outside access and so on. And that's really the difference. I can draw it on whiteboard with stuff if you want more. Yeah?
Another question. Your model sort of relies on a very passive role of objects. They're just sort of waiting for being called by a client and then calling perhaps other objects to help them execute their task and so on. So in that model, of course, the RPC is okay, reasonable. But have you thought of other communication models where the objects are more active, they run a process, and so the processes would have to communicate with different object worlds.
One of the things that was kicked around in the first object war was that sort of question, and do we go for an actors model where every object notionally has its thread of control and is autonomous and active? And remembering that 386 4-megabyte machine with a single-threaded operating system, it seemed that would be kind of heavyweight to do what we needed to do. And mentally what I did was separate the concerns and say I've got composition of components and I've got activity. And I can put up some set of objects that are composed together and give them a thread, and then let them run autonomously and communicate with other things. So I factored the threading away from the objects and said you can combine them in interesting ways. And that's where you get to the apartment model in COM, and the rental thread pooling model in MTS, and the context work being done in COM Plus right now. That is variations on ways to provide that, but keeping it separate from the component model or the object model, because they're kind of somewhat separable properties. They're not completely separable because any component is going to assert requirements on its usage, like don't call me in a multi-threaded fashion, because if you do, I won't work. And therefore, if you want to use this thing for multiple threads, you have to put a guardian around it. I guess we used a full hour. Okay.
Thank you very much.
Thanks. Come back next week.